Hello, in this tutorial we will overview basic concepts of C# scripting in Unity 3D. Let's go ahead and launch our program and let's create a new project which we will call Intro C# Scripting and create project. Scripts are a very important part of learning Unity 3D. If Unity were a real engine, then imagine the script components would be the fuel necessary for that engine to operate. When we first launch Unity 3D, we're given a series of default settings. For this specific tutorial, let's make sure that we all follow the default layout, which you will find on the upper right corner, default. This would allow us to access the console in order for us to write scripts and somehow test our variables here. So I'm going to switch to project. So when we first launch Unity, we are given two main game objects here. One is a camera, the second one is a directional light. But most everything that makes up a scene in Unity is a game object. For instance, the default components that come with the program, or objects that we can import from other programs, or ones that we could create within the program. And objects are basically data container for components. If we select a game object, then in Inspector, we would be able to look at its different components. All components that can be modified in inspectors are made of scripts that are preloaded, or scripts that can be attached to object, which is something that we would look at shortly. Sometimes you will hear these two terms, scripts and components, used interchangeably, as the built-in scripts and the ones you add change the attributes of your object. Now let's go ahead and create our very first script. Let's go to our assets folder and first create a general folder by right-clicking, going to create folder called scripts that would contain all of our scripts. Now this folder could also be accessed by going to your project folder under assets, and you would find that folder here. And close this. Now double click on scripts and right click again, go to create, and select the C# script template that is provided by Unity. Now the name of this C# script would always be new behavior script. Let's rename this as hello world, as often that would be the first script that you'll be writing in any scripting environment, and click out. Now if you look at your inspector, your display components change to looking at the overall syntax of this default script. We want to now be able to modify this, and that does not really give me that possibility. So if you double click on your C# script, we would be able to launch Unity's MonoDevelop environment. Now MonoDevelop is the default editing environment that is provided by Unity. If you do not see this, or later on if you want to use other platforms such as Visual Studios, you will be able to go to your edit menu, go to preferences, and under external tools, you will be able to select one. Now by default, you should have MonoDevelop already preset and selected. I'm gonna click out of this. And then if you go to your taskbar, you should see that MonoDevelop is a separate window that is going to be accompanying what we're building in Unity 3D environment. This is a default script that has all the components necessary for this specific script to communicate with Unity environment. It also has a general class that would allow us to write variables and functions, and through these main lines connect to the environment. We have two main functions that is provided with this default template. One is called void start, which is triggered at the beginning of the class, and it's run once. And we have void update, that will be called throughout the game as Unity goes through and runs the game loop. Now let's switch back to the main window and attach the script to one of the game objects that we have. So for this, you would select your script and you would drag over whichever game object you want to connect it to. For instance, let's connect it to our main camera. Now, if you left click on your main camera, all the way down here, you will see that that Hello World script is attached to this specific game object. If I do not want to work with this specific script anymore, I could just check this off and this script would not be attached. But for now, let's keep it checked. Let's make sure that we save our project and use Command S or Control S to save this specific scene. So this takes me to my asset folders. I'm going to right click here again and create a new folder called Scenes. And inside Scenes, let's save this as our intro C# scripting 1 and save. Great. Now let's go back to our MonoDevelop. Now we talked a little bit about the structure of our script. We have our general libraries that allow us to connect to Unity 3D environment. We have an overall class. Now the name of this class is the file name that we've created, and we have two main methods. But in order for us to add values to the script, we're going to need to create variables. And depending on where we place these variables inside of our script, whether it's inside each of these methods or whether it's declared as a global variable for the specific class, these variables are going to behave differently. So we're going to create our very first variable here, and we need to do that always by declaring the specific type. I'm going to create 2 lines of space here so you will be able to see this a little bit better. I'm going to create an integer variable first. So I'm going to first declare that this is an integer type. And as soon as you start to type, you see that there's all these suggestions, and depending on the type of the syntax, then it has this different abbreviation. So whether it's a function, whether it's an event, so you would start to get these suggestions from the environment. We're going to enter. Then the next thing we're going to do is we're going to declare a name for our specific variable. In this case, this name could be anything. So for instance, a space equals, let's provide a value, let's say 5. And you always need to close your declaration with a semicolon. So now we have an integer variable declared with a value of 5. Right now, there's nothing really specific about this variable, and we're not really accessing it anywhere. One of the ways that you could start to check to see if your script is working is by using your console to verify information. So right now, there's nothing printed in our console. Let's go back to our MonoDevelop. And we set that we have 2 functions, void start that's run only once, and void update that's constantly being, it's calling functionality. So in this case, we want to use a functionality inside void start to print the value of this variable in our console. So this is a command that we're going to be using quite a lot that would allow us to verify our functions. So we start off by typing debug, and it doesn't really matter how I'm typing this, whether I have it uppercase, lowercase, it gives you suggestions. So what's great about this interface is that it gives me also a description of what I'm trying to do. So debug is a pre-existing class that contains methods to raise debugging while developing a game. And part of this process is one of the functionalities that we're going to access of debug. And anytime that you want to access functionalities within a class, so debug is a class, I want to access one of the functionality, you use .log, so that allows us to log the information which is part of our debugging in the console, and enter. And you always have to tell it what is it that you want to log. So you always place that information within parentheses, and as mentioned, anytime that you are providing a command, you need to close it with a semicolon. So inside parentheses, we're going to declare that what we want to log, or what we want to print to our console, is the variable a. Enter. So anytime that you write, you update or write anything in your script, you need to make sure that you save it, and this way we could then see reflection of this in our Unity environment. And our script is not really accessed unless we are in play mode. So if you now press play in our console, we should see the value of 5 printed. So this becomes a way for you that you can make sure that my script is connected to my game object, and I'm able to verify a variable. Let's come out of our play mode and go back to our MonoDevelop and start to look at a few other data types, in this case, that we could use as variables. And we're going to continue using our debug log functionality to then communicate with our console. So our second data type that we're going to be using is a float data type. So floats allow us to then work with decimal numbers, and I'm going to call, in this case, float b. And let's use the same range. I'm going to say, in this case, 5.5. Now, one thing that's very specific to float data types versus integer, that you always need to specify at the end of the value that this is a float type. And you do that by providing a lowercase f. Then we're going to close our function. Now we're going to use the same setup here. We're going to say that we want to debug.log, then open close parentheses. So I don't really need to provide a space in between, but this is not gonna throw an error. And then we're gonna close our functionality, and then go inside parentheses and provide your variable b, and save again. Go to your Unity game environment. It's always recommended that when you are when you want to verify new information, you press here clear your console. Otherwise, sometimes it becomes a little bit difficult to identify what was there before, what you're logging again, and then press play again. And now we should see both of those variables logged in our console. So the first one is an integer type, second one is a float type. Come out of the game space again, and let's go back to our MonoDevelop, and we're going to provide our third data type, which is a string data type. Strings allow us to provide text inputs. So type string, enter. Let's call this text equals. Now we want to tell what this variable text contains. And anytime that you're working with string type, you always want to place the name inside quotation marks, and you close that input. So go inside quotation mark, and you can provide any input. Let's say I'm going to say testing with an exclamation mark. So let's go ahead and now print this to our console as well. You can debug, enter. We're going to log this, and name of our variable. And I always open close parentheses together, text. Now go ahead and enter and save. Go back to your Unity environment. I recommend clear your console and press play again. Now we should see also our string type printed to our inputs. So far we've seen how to write variables and be able to see those inputs in our Unity environment. But as I mentioned in the beginning of this tutorial, the components that you see in Inspector, these are ultimately preloaded scripts that are provided for us. So next up, we're going to look at how to use variables that we're writing inside our script and be able to see them inside our inspector. So I'm going to go back to our scene, go back to our MonoDevelop. So the difference between the variables that we've declared so far and the ones that we've seen in inspector is the type of access that Unity has to these specific variables. So if you look at the class, the main class that this script has is public. So public is a type of information, whether it's a class or whether it's a variable, that could be accessed from anywhere in the program. However, if you do not provide public in front of a class, in front of your variables, then that is going to be specific to where this information is contained. So if we take the same information here and in front of here integer a, if we write public, enter, now this variable will be accessed from our console. So press save, go back to your Unity environment, and now you should see that variable appear right under name of your script. So the name of the variable is a. Obviously we can change this to anything we want, and the value is 5. Now if you hover over a and use your mouse, you should be able to increase or decrease this input. So this is different than, this is not going to replace the value that we have inside our script. That value 5 is hard-coded. So imagine when you open your default setting, there's these values, in this case scale 111, that's hard-coded inside. So that's something that's provided inside the script, but it's definitely something that you could select and modify. So let's do the same for our other variables. So let's also declare our float as a public type and also our string as a public type. And save. Go back to your environment. And there you go. Now we have our variable a, b, and text. If we compare what we've created to rest of the inspector, you would see that sometimes you have a variable name and that variable provides either a text return or it provides a value, right? But we have also sometimes the option for elements to be checked on or off. So these input types are Boolean input types. Either their state is true or false. So let's go back to our MonoDevelop and create another input type that's going to be of Boolean type. And let's keep that public so we can access it in our inspector. The type is going to be Boolean, so B-O-O-L. And let's provide a name. Let's call it turn on. I'm using camel case equal. And in this case, because these options are Boolean, on or off, I'm going to say that when you first launch the inspector, the option is going to be true. And let's close the statement. Now save and go back to your inspector. We should have our Boolean option here created, which I could either create on or off. Now if we go back to our MonoDevelop and change the default state to false, then as you can imagine, when you first launch your inspector, the option would be turn off. Right, so now let's take a look at how to combine these variables. I'm going to create a new debug option. Debug.log, and inside parentheses, let's look at combining our variable a and b. So we would just use a plus b. Save. Let's go back to our console. If I do not clear this, then it's going to print again, but it's going to override the first three. I clear, and let's play. So we see our integer, float, string, and then combination of our integer and float. One thing you're going to notice is that my first input does not correspond to the value input that I have here. So we had hard-coded 5 for integer a. However, when we were working with the variables here, when I was going over this, I started to modify this. So as I mentioned before, you are hard coding these numbers, but you have the possibility to adjust them along the way. So right now, that is the number that's being reflected. However, in my case, the b variable was not modified. So if you were following along and changing these numbers, you might have different inputs here. Let's try that one more time. So for me to be able to make changes and for it to be reflected in our console, I need to come out of the game mode. And let's modify this. For instance, I'm going to do 14 for a variable. I'm going to change my b variable. I can also change the text input. Let's say game over. Right? And in this case, my Boolean option is not connecting to everything. So I have my 1, 2, 3 variables here, and then the last one is one that's being hard-coded from our script. So I'm going to go ahead and play this again. Now we should see these numbers reflected here. Hope this clarifies the way that we can work with variables in Unity. Let's go back to our script, coming out of my game mode, going back to the script. And let's start to also look at a way where we can use the debug function, but we don't really specifically work with only printing variables. So if I'm done working with variables here and debugging, I can start to comment out certain aspects of my code. So here I briefly mentioned that we can use double slashes in order for us to comment out a line. So let's try with our integer input. We use double slash. Now the rest of that line is commented out. Or if I want to comment out multiple lines, instead of using this double slash for every single one of these lines, I could use another method, which is using slash or forward slash again, then your asterisk, and you can see that now I'm commenting out everything else after that point on. So if you have a big chunk of code that you want to comment out, this is a great method of using it. But then the problem becomes that if I want to use my void update, or in this case, use pretty much this class because my curly brackets here are not going to match anymore, then I need to close this state. So to do that, then we would repeat the symbols, but in the opposite fashion. So I'm using forward slash asterisk, and I'm going to end that with an asterisk and forward slash again. So now you can see that only that portion of the code is commented out, but that allows us to work with multiple lines. So I'm going to create some space underneath and say that this time we're going to use the debug command again, .log. So this is one of the ones that we're going to be using quite a lot, but instead of printing a specific variable, I could just print a specific text. So I'm going to place that in quotation mark, and for instance, I could say, I am playing. Save. And let's go back to our console again, clear the console, and play to print this information. So I am playing. So this just clarifies that we can pretty much print anything in our console. And again, this becomes a great way for us to check status of our code. So we mentioned that we have two main methods or functions in our main class: void start, which only runs once, and void update, that could run multiple times. inside void start or in void function, not only we can declare variables, but we can also declare other methods or functions. So you're going to hear the term function and term method used often interchangeably, and there's a slight difference between them, but you can pretty much group them for now as one thing. So instead of declaring debug log inside void setup, I want to write a specific function for just declaring this state I am playing. So void functions are functions that do not really return anything. So everything that I write inside this void function is going to be within visibility of these curly brackets. You declare the type of the function, which is a void type, meaning it doesn't return anything global for the class. Then you declare a name. Now, void start and void update are names that are recognized within the program. However, we can use the same structure and write other void methods using the same structure but provide other names. Anytime that you have a parentheses, it means that you're going to be declaring variables inside, and inside curly bracket, then you tell it what to do inside that function. So I'm going to leave my void update alone, and we're going to declare a new function underneath, which is going to be of the void type. And let's provide the name. We're going to say play. And this name of your void function does not have to be capitalized, but it's more of a convention that lets you know that this is a void function. Then I need open close parentheses and open close curly brackets. And I'm going to take my debug log I'm playing function here, and I'm going to cut this by using Command X or Control X and paste it here. So it's the same command, but let's see that if we are able to print this in our console right now. Do save your code, go back here, clear, to console, your values, and play again. Now, even though it's the same function that I'm declaring, but I do not see anything printed in my console. The reason for that is that for this function to be able to understood by our class structure, I actually need to tell it whether I'm going to be playing this or using this function inside void start or void update. In this case, I wanted to be printed right in the beginning when I play this, so I'm going to actually call this function, not specifically debug.log, but the whole void method inside void start. And you're always going to do that by using the name that you're providing for this. So in this case, the name of my function is play, and you open close parentheses, meaning that there's some information without this inside this method, and you close that. And save again. Go back to your console, come out of your play state, play again. Now that information is printed. So that pretty much shows us that this structure of void setup, void start and void update could be manipulated by either writing functionalities inside or functionalities outside that then could be accessed inside void start and void update. Thank you for watching this tutorial, and in the next tutorial we will look at writing conditional statements in C# for Unity Engine.